Hello, welcome back. We're working on Y delta three-phase circuits. We have our first problem. This is a baby problem. It's not even a full-blown problem. It's really just trying to give you some practice using the shifting formula. So what we have for this problem is in a balanced three-phase delta connected circuit, the phase current, now you should know what a phase current is. It's the current through the load, each leg of the load. In this case, it's a triangle. ICA is magnitude 15, 38 degree phase. Amps, which is an RMS value, which is always the case for these problems. For a positive phase sequence, what is the line current, ICC? So this isn't even a fully baked problem. We're not really asking you to do anything crazy or extensive. Literally, they give you one number, which is a phase current, ICA, and they're just asking you to find the line current, and we're nice enough to label it's ICC. So for future problems, we won't even do that. I'll just tell you something like the phase current for the C phase is this, and you have to know that that's ICA because it goes AB, BC, CA. So CA is the phase current for the third leg there, for the C phase. And then the line current, you should all already know, are labeled AA, BB, and CC, right? Those are the line currents. So we're labeling them for you. We're babying it a little bit even more, but in the future, we won't even give you that because you should know from the words what it actually means. Anyway, we're given the phase current, ICA. So if you go over here to this drawing, this is kind of what we had left before. You have three phase currents in a delta load. You have AB, BC, CA. So this is the one that was given to you, all right? And what they're asking you to find is this one here, this line current. This line current is I little c, big C, right? Because coming into the A line is little a, big A, little b, big B, little c, big C. And we now know that for the A phase, we always do it in terms of the A phase, we have a relationship between the line current and the phase current, AB. We were given that before. There's the same exact relationship holds between the line current coming through phase B and the phase current BC. The exact same relationship holds between the C phase line current and the C phase phase current. So literally when you know what, you kind of center yourself on what's happening here, we're just given the phase current and we're asked to find the corresponding line current. So this is the phase current for the C phase, this is the line current for the C phase. So if you remember back, the relation that we were given, that we talked about so much, was for the A phase. We always write everything in terms of the A phase, and I encourage you to do that in this case also, and that is I little a big A, that's the line current, is equal to the square root of 3 times the phase current. So for the A phase, that's AB. And then it's angle negative positive 30 degrees. You should always remember the formula for the A phase. That way you don't have to memorize a bunch of different formulas because nobody likes to remember things. So just remember the anchor formula, the one that you can get everything else from, and just remember that one. Pour your energy into that. Memorize this formula, and then now you know, well, I'm not really dealing with the A phase, I'm actually dealing with the C phase. But the exact same principle holds because instead of IAA, it's going to be the exact same thing, but IC big C. The square root of 3 is going to be exactly the same. The corresponding phase current is not IAB, it's ICA because it goes AB, BC, CA. And then the phase angle is going to be exactly the same, right? So in this case, you have to ask yourself, well, what am I given? I'm given ICA. I'm going to plug that in a second. So let me write that down. I know that ICA is 15 angle 38 degrees amps. So I'm going to stick it in here, and literally it's just going to be a straight calculation to find out what the line current is. But we have to choose what is it going to be, positive or negative phase shift. So you go back to your problem. It says for a positive phase sequence. So the way we write these things in this kind of way to remember it is we write it like this. The top sign we pick if it's a positive phase sequence, and the bottom sign we pick if it's a negative phase sequence. So since this is a positive phase sequence, it's actually going to be a phase shift of negative 30 degrees. So from here on out, you don't have any plus or minus. You have already chosen it because it's locked in based on what the problem statement is. So then you go off and you say, well, then ICC is going to be the square root of 3 times 15 angle 38 times, really when you have this angle kind of sitting over here, it's really 1 at an angle of negative 30, however you want to write it down in your paper. Ultimately, you're going to multiply these magnitudes together, and you're going to add these phases. Or you could just stick it in your calculator, and that's what it's going to do. And so then ICC, the line current, is going to be 25.98 at an angle of 8 degrees. And of course it's amps RMS. So that's it. And that's the line current. So not a hard problem, obviously. It's not even, as I said, it's not even a fully baked problem. There's nothing to do here, right, other than just give you practice with this equation. That's what we're doing. So the next couple of problems will be in slightly increasing complexity, just kind of giving you a little practice. And then finally, we'll give you a real problem, which will have a source, a line, a load, and you'll have to shift to get the right currents and then the right voltages, and it'll be a logical progression, but it'll be easy to do because we'll take baby steps. So follow me on to the next lesson, and we'll do a problem. Again, it's kind of a baby problem, but we'll give you some practice using these equations for Y delta three-phase circuits.